Hey guys, welcome back to the channel. Today we're going to be talking about some of the more common tools that I use throughout the machining process. To start off, we'll start with like a basic tool holder and an end mill. So this is a CAP 40 tool holder. It's a ER32 collet holder specifically. So that means it uses collets specific to the size of the end mill to hold them in place. So what I would do if I was to say set this up is I would take my collet, this is a 3/4 inch collet, snap it in the collet nut, and then start to thread it in the tool holder. And then right before you get tension on it, you'd slide your tool in there to whatever length you may need, sticking out of your tool holder to make sure you have clearance, and then tighten it down. To actually tighten it down, you'd get the proper wrench and put it in a holder to tighten it down, but that'll work for now. Another pretty common tool that we'll use is parallels. When you buy them, usually you get them in a set. This is a very basic set. They'll start off smaller, so this one's a 1/2 inch parallel, and they just get up bigger by an 1/8 inch increments, and the largest one is 1 5/8". What these are used for is if you're using some hard steel jaws in a vise, and maybe you're just grabbing some raw stock, you put the parallel in, and then you set the stock on the parallel. And this gives you the ability to adjust the height. Say you need a little bit more material sticking out of the jaws, or maybe you're gonna cut a little more aggressive, so you want it lower down in the jaw, or whatever your particular instance might be. These give you the ability to vary the height, as well as give you a solid parallel surface that you can put your part on so it's holding true. Some more tools that we'll use would be gauge pins. This particular set is just over 1/4 inch to a 1/2 inch, and these are minus gauge pins, which means that the tolerance is either 0 or minus 0.0002. So pretty much you can say that it's a 1/4 inch pin or a 1/2 inch pin, but if anything, the pin is slightly undersized, which is all the minus means. And then they have plus gauge pins as well. That means if you have a perfect 1/2 inch hole, a 1/2 inch gauge pin will fit, versus if you have a plus pin, a 1/2 inch gauge pin might not fit because it could be slightly oversized. They're pretty basic on what you'd think. It's just a pin. It's labeled with its size and they're precision ground to that size. They're used for checking the diameter of a hole. If it fits, then it's that size. If it fits with some slop, then you step it up 1 thou or however much you may need to check the diameter of a hole. Another really common tool is a 1-2-3 block. They also have 2-4-6 blocks. It is exactly what it sounds like. It's a block that's dimensioned 1 inch, 2 inch, and 3 inch. They're made out of hardened steel, so they're not going to be dented if you have to use them in the machine or whatever, but if you drop it, then it can. What they can be used for is maybe you need to shim something up in the machine, or I'll use it for setting location points in a vise, put it in the vise, push it up against a stop, and use this because I know all the sides are true, perpendicular, and flat, so it's an accurate reference. You can also use it to calibrate your tools. For example, if I took my calipers here and wanted to reference and make sure that they're measuring true, I can measure it on here and see, well, now I didn't get a perfect measurement. That's embarrassing. I could take my calipers and measure the direction that is 1 inch, 2 inch, and 3 inch, and assuming that the calipers are calibrated correctly, I'll get the correct measurements, and then I can trust these calipers. The next tool I'll be talking about is a tool height gauge. What I'll use this for is you put it in the machine, and then I'll lower my tool onto this button here, and maybe you can see it. When I push the button, that dial moves, and then when the dial gets to 0, I'll stop and hit the button on the machine that measures the height of the tool. So I'll do that to every single tool in the machine, and then I have a perfect location so the machine can reference that when cutting, because each tool varies in length. Maybe the tool holder's longer or the tool's longer, whatever it may be. Another tool I'll use, this one's a little bit less common just because the accuracy is so high that it's not always necessary, but it's a very good tool to have, and definitely one you need to know how to use. If I can get the case open. This is a micrometer. So micrometers are limited to the size that they can measure. This particular one is a 2 to 3 inch micrometer. That means that it's limited to measuring things that are from 2 inches to 3 inches, no more and no less. The reason it's so limited is because how accurate it is, that it just doesn't have the universal measuring aspect that, say, a caliper does. We can measure this 1-2-3 block. You'd tighten the screw, and then it has a ratcheting on the end so you don't over tighten it. And then once it's done ratcheting, you can lock it, pull it off, and look at the measurement. Since this is a 2 inch dimension on the 1-2-3 block, it measured exactly 2 inches. Micrometers can be a little bit more difficult to read than, say, a caliper. When you're cutting parts and trying to be accurate, it's definitely something you need to know how to do. There's definitely a really important tool to have. This next tool is something that's used in the machine only. It is a 3D sensor is what it's called. So a lot of machines will have probes This particular one does not, so this is what I use instead. So this actually goes into the spindle of the machine. You don't ever turn the spindle on with this in the machine, but I can use it as a location. So whenever this ball on the end here moves, it moves the dial. So whether I move it forward, backward, left or right, or any direction in between, or even up and down, it'll move that dial. So what this does is I can push this on the side of a part, and once this dial hits 0, I know the part's exact center line of the spindle is in a line with the edge of the part, and then I can hit part 0 set on the machine, and it tells the machine exactly where that particular axis is. The next tool we're going to be talking about is some thread gauges. So these are called go, no-go thread gauges, and it's exactly what it sounds like. So this is just like a standard set of your really common thread sizes: 1/4 20, 3/8 16, 5/16 20, 5/16 18, 1/2 13, and things like that. This particular one is the 1/2 13. One side labeled go. So that side, when you're thread milling or tapping a hole, that needs to thread in for it to be a thread that's in tolerance. And then this side says no go. So this side is actually manufactured oversized from what is considered in tolerance. If this side threads in and this side does not thread in, then the thread is good. But if this side, the no-go side, threads into the hole, you know your threads are oversized and therefore they're out of tolerance. The part could be scrapped. Like I said, this is a very basic kit. It's just more or less a starter kit, and then you can either make your own or buy other thread gauges as needed. An example of a thread gauge that you could make, this is a 2 3/8 16. It's the thread gauge that I use when I'm manufacturing the coil covers. The little threaded caps on the top, just to make sure I keep them consistent, even though I mill both halves of that thread. So in theory, I could make them whatever size I want. What I did was I went in the machinist handbook and I looked at the pitch diameter and the major diameter of the threads themselves and got some thread wires and measured these threads while I was manufacturing this. So that guarantees that I know that if this threads in and it's just snug, but it threads in, then the threads are in tolerance. An ideal set, I would have a no-go thread gauge, but I do not for this particular thread size. And then I did a similar thing when I manufactured this, which is just the reverse of it, so that I can check the caps when I'm manufacturing those. And that just keeps everything consistent so that I know that a cap I make today would thread into a coil cover I'll make in a year from now, or whatever it may be. The two final tools kind of go hand in hand. They're both calipers. I would say it's probably the most common tool that I would use. You saw them earlier. They're just a very basic measuring tool, but in comparison to every measuring tool in the world, from tape measures to rulers, they're rather accurate. This set goes to 1/2 thousandth, so that is the 4th decimal place from 0. Kind of a general rule of thumb when you're looking at a drawing, if a tool like this measures to every 1/2 thousandth, you multiply that by 10, so it gets you 5 thousandths, and that's the tightest tolerance that you should measure with that particular tool, just because everything has a tolerance within itself, and maybe your tool is measuring off a little bit. So it's just a good idea to follow that rule of thumb to always make sure your parts are in tolerance. This particular caliper is a Mitutoyo 8-inch caliper. It's kind of been my go-to. It can be a little bit big. I've just gotten used to it. I really like this set of calipers and I've been using them for a long time. And as long as you put them in their case and clean them off, then they last a really long time. There's multiple types of calipers. So this is, for the most part, an OD caliper. Most of your measuring is going to be between these two surfaces, so you're going to be measuring the outside of something, like this, for example. Although, that being said, you can use them to measure ID with these two surfaces, or depth with the bottom here to the end of this pin. There's various different ways to use them. I feel like I'm seeing Instagram videos or YouTube videos all the time of different ways that you can use your caliper. They're a very, very nice tool to have. Definitely a good start if you're getting into machining or really any sort of CAD work. Maybe you're into 3D printing or whatever it may be. Calipers are a really good start. Another type of caliper that I use is an ID specific caliper. This one is nice because it has the ability to measure in like an O-ring groove. So I don't use these all the time, but you can see it's these two points of contact that is actually doing the measuring. You have to be careful because they're obviously very small and you don't want to bend them, because as soon as you bend them, they're not accurate anymore. You can measure in like an O-ring groove because it can reach inside something that has a larger OD than the bore itself. It's just another really good tool to have. This particular set is a 6-inch set, and I've never really had the need to have a larger set, so I don't, but they do make them. Another tool that's really handy to have, a little bit more on the expensive side of things, but nonetheless it's an important important tool would be the surface plate and a height gauge. This is nice because it's a precision ground surface so that you know it's actually true up to a tolerance. And then the height gauge is nice for various reasons. You can put a tool in like that, zero down on your surface, and measure the height of a part or from various steps in a part. Or you can put a dial indicator on it like I have, zero out on a set surface using some gauge blocks or a 1, 2, 3 block or something like that. Whatever the dial reads, maybe it's plus a thou or minus a thou, whatever it is, then you'll know that's how far out of tolerance you are or out of a nominal value you are. It's a really good thing to have in the shop. It's very important. Definitely something that if you get into more production style stuff that you need to have. We just have this little one kind of tucked away, but when I need it, I use it, and it's very handy to have. These are some of the more common tools that we use. I'm mumbling so you don't use this part.
I'll use it.
Damn it.
These are my best friends.
Who I hang out with every day. How am I saying this? I'm getting lost in the sauce. A table. Check the fit.